Alright guys, welcome back. I'm here to do a video, and today I'm going to be doing a video on binomial expansion. Now, I had a student come to me and ask me for some help, and let me show you a type of binomial that she gave me that she wanted me to work out. And in all honesty, it had been a little while since I had done these, and I remembered that there were some tricks to these, so let's go ahead and get started. Alright, if just in case, if you don't know what binomial expansion is, it's where they give you a problem like this. They give you, say, x plus 1, and they might simply ask you to square this. Okay, and the reason why they call this a binomial, meaning two, you have two quantities inside a set of parentheses. Okay, so basically you have this expression, these two things, and it's known as a binomial, because you got two terms, and those two things are being squared. Okay, now it could have been to the first power. If it had been to the first power, you would have just written x plus 1, but here we've got x plus 1 squared. Okay, so let's talk about this. Since you got x plus 1 squared, what that means then is that you're going to have to write this down: x plus 1 times x plus 1, and you're going to have to do the full method to work this out, which, if you go x times x, you get x squared. You go x times 1, you get 1x. And you do the other term, x times 1, you get 1x again. And then you go 1 times 1, and you get 1. And then you're supposed to collect like terms. You get x squared plus 2x plus 1. Okay, so this is what you would get if you were to square a binomial. And then it gets more fun when they ask you to basically take the same binomial, and instead of squaring it, they ask you to cube it. Well, you go through the same process. You have x plus 1 times x plus 1 times x plus 1. Now, you can kind of help yourself out if you are having to do, say, the first, I don't know, say 5 or 6 of these. You can always look back at the previous one that you have multiplied, and you can get that first multiplication, so to speak, of the first two. So since we've already done these first two here, you could just re-record it down here: x squared plus 2x plus 1. And then you're going to have to, once again, multiply it by x plus 1, and that way you'll get the cubed. So I don't mean to bore you with this, but you will have to FOIL once again. You get x cubed plus 2x squared plus 1x plus 1x squared. Now, a lot of times, instead of doing it out all the way to the left like this, I used to cheat as a youngster and I would simply just not do that right there. What I would do is, let me erase some of this. What I would do is I would just simply write it below the term, because we went x times x squared is x cubed, x times 2x is 2x squared, x times 1 is 1x, and then when we start with the next one and we multiply x squared, we get 1x squared. What I would always do is I would always write it below as I get plus 1x squared, and then you take the 1 again and multiply it with a 2x, and you get plus 2x, and then you take the 1 again and multiply with a 1, and you get plus 1. And I would go ahead and add these up and get x cubed plus 3x squared plus 3x plus 1. Okay, and you just do this little method all the way through, and you can find these terms. And the student was just like, is there an easier way to do this? And I was like, well, there is. You can use Pascal's triangle. And she's like, Pascal's triangle? I'm like, yeah. She's like, what's that? I'm like, oh, well, I didn't know what the math teacher was teaching them, and they probably hadn't made it to Pascal's triangle. Maybe this was the right before doing the Pascal's triangle. That way they could show much appreciation towards the Pascal triangle. But I told her, I said, well, let me go ahead and show you Pascal's triangle. I said, it's really for binomial expansion. And she's like, really? I'm like, yeah. She's like, well, okay, show me. So let me go ahead and show you what I showed her. Okay, so you can see that this can be rather long and it can be time consuming. Okay, yes, it is, and it's easy to make a mistake. So what I did is I showed her Pascal's triangle. I'll write it in a different color here. Let's just choose orange, maybe a dark. No, yeah, let's go orange. All right. So I told her, I said, well, in Pascal's triangle, you start with writing a 1. That'll be our first term in Pascal's triangle. And she's like, okay. And I told her, I said, well, underneath the 1, we're going to write another 1. Okay. We're just going to build a series of 1s. She's like, okay, I got this. This is pretty good. I'm like, okay, well, good. And I said, then after you build these 1s here, you branch out and build you another 1. Okay. But this time, we're going to take these 2 1s and we're going to add them together and we'll get a 2. And she was like, whoa. I said, yeah. I said, it's going to build on itself. And she's like, okay. I said, so basically it's kind of like you're going to have levels in here. And maybe you'll see a triangle appear soon. She's like, okay, well, keep writing. I said, okay. So here we go. I write down another 1. And I said, now we're going to add these terms together. And we'll get 3. She's like, okay. I said, now we're going to add these terms together. And we'll get 3. And then out to the side, once we get past the insides of being able to add terms, we write another 1. And then I showed her, I said, if you don't see this, look at it this way. I said, here we only had 1 term. We really didn't have much of a choice. And she's like, okay. But I said, when we got to the second terms, we could write a 1 out there and a 1 there. Still didn't have a middle. I said, but here, what we would do is we would just take these 2 numbers and we'd add them together and get 2. Then we take these 2 numbers, add them together, and we get 3. Take these 2 numbers together and add them together, and we get 3. And I said, and basically what that's doing is that's creating like levels. You know, there's that one, there's that one, there's that one. Okay, but I said we really want to just mainly focus on the levels and how we're creating them. So, you know, I told her, I said, all we got to do is just keep recreating these 1s. Okay, and she's like, well, what's the purpose of recreating these 1s? I said, well, these are going to be the coefficients of our binomials once we multiply them out. Okay, and she was like, oh, okay. I said, but that's only true if the coefficients in front of those binomials are 1s. And she was like, oh, okay. I think I understand. And maybe the rest of you might be able to understand once I finish writing most of these out. But I think what we'll do is we'll stop on this one. Okay, so we've got 5, we got 10, we got 10, we got 5, and then we'll have a 1. Okay, so let's stop on this one. Okay, so basically this is if you have the number 1. Okay, so basically that's the number 1. So let's write that in, I don't know, say purple or maybe hot fuchsia. Okay, so this one is if you've just got 1. This one is if you've got 1x plus 1. That's what that binomial is. Okay, right there. And she's like, okay, so the first one was for 1, so that's for 1. This one is for x plus 1. I told her the next one now is for 1 x squared plus 2x plus 1. She's like, okay. I said, yeah, that's it. And then the next one is, you know, we got 4 terms, so it's going to be 1 x to the 3rd plus 3x squared plus 3x plus 1. And if you look, that's what we got right here. Okay, and that's really neat. And I told her what you can do is if you're asked to multiply out a binomial that's rather large, okay, so notice that this goes out to the 3rd power. It's got 4 terms though, 1, 2, 3, 4. It's got 4 terms. If you notice when we get out to here, this is the third power, this is the fourth power, this is the fifth power, then this is going to be the series of numbers for something, some binomial that's been raised x to the x plus 1 raised to the fifth power. Okay, this is like, okay, I think I'm getting it. I said, well, okay, good. So, you know, I told her, I said, what we can do is we can actually take this Pascal's triangle and figure out what the binomial is. And she's like, okay, well, show me how to use this Pascal's triangle. I said, okay, let me show you. All right, and she had a problem, and this was the problem that she had, or one very similar to it. She had 2x plus 3 raised to the fifth. And she's like, I don't know how Pascal's triangle is going to help me to solve this. And I told her, I said, well, it will. I said, just watch. Okay, so I hope everybody can follow along with me. So this is x to the third, this is x to the fourth, and this is x to the fifth. So this binomial that we see here is for x plus 1 if it was raised to the fifth. Okay, these are the coefficients that we would get, because look, we've got 1, 2, 3, 4, 5, 6. We got 6 terms. Okay, but we're going to use that one to help us work this one. I know you're probably saying, I don't know how in the world you're going to do that. Well, let me show you the greatest thing about Pascal's triangle, and it's going to be this. Okay, all right, we've got 2x plus 3 for our binomial that's being raised to the fifth power. Now that's a lot of work to multiply that out 5 different times, and it's a lot to keep up with, but Pascal's triangle will help us. Alright, so this is what we're going to do. We're going to pay really close attention to the coefficients that we have here in orange. Okay, so watch this. Alright, here we go. Alright, exciting times. Alright, so we're going to have an x, and that x is going to have to be raised to the fifth. The next thing that we will have is we'll have an x to the fourth. The next thing that we'll have another one that's x raised to the third. Then we'll have another one where we have x is raised to the second. Then we'll have another one where x is raised to the first, and eventually we'll have our constant. Okay, now if we look up here, we've got the numbers for Pascal's triangle for the coefficients. Let's go ahead and record those now. Okay, so I'll use the same color, orange. All right, so we've got 1, we've got 5, we've got 10, we've got 10, we've got 5, and we have a constant of 1 over here. Okay, so there's all those numbers. Now, the other thing that we have is the 2 and the 3. Okay, now the 2 on this end is going to be basically 2. This is going to be times. This is going to be 2 raised to the fifth. On this next term, it's going to be 2 raised to the fourth. On this term, it's going to be 2 raised to the third. On this one, it's going to be 2 raised to the second. On this one, it's going to be 2 raised to the first. And then over here, it's basically going to be 2 raised to the 0 power. You know, we're not going to have it there. That's just going to be another 1. All right, but I just want to make sure you see the countdown. 5, 4, 3, 2, 1. Oof, that's an ugly 1. 1, and then 0. Okay. Now, we're also going to have the same thing with the 3, except it's going to be in reverse. Starting on this end, we're going to have 3 raised to the fifth. And then we need to fit our 3 in it over here as well. Now I'm running out of room, but I'm going to try my best to squeeze this in. So now we're going to have 3 raised to the fourth. And right here we're going to have 3 raised to the third. Here we're going to have 3 raised to the, well, it went 5, 4, 3. This one will be raised to the 2. This will be times 3 raised to the 1. And then this last one, of course, will be 3 raised to the 0 power. Okay. Now, you're probably wondering, where are your plus and minus signs at? You just got all this stuff written down. Well, since we have a positive sign here, then all the signs in between these will be positive. Okay. Now, after writing in those plus signs, we definitely need to clean this up a little bit, okay? So we're going to punch this into the calculator. So let's go ahead and pull up our TI-84, and let's just punch this in. All right, let's deal with each quantity at a time, okay? Now this, it does seem like it's a lot of work, but it just looks harder because I'm having to show everything on the screen. Let me blow the calculator up, make it bigger, so, zoom in on it or expand it so we can see it a little bit easier. Okay, so we've got 3, and that 3 is going to be raised to the 0 power. Totally not necessary to write, but I'm showing you every step. 3 to the 0 times 2 raised to the 5th, okay, times 1, which is technically not necessary, okay, but that number is 32, okay, so we will write 32 x to the 5th plus, now we need to clean up the next one, okay, alright, let's attack it. We've got 3 to the 1st, 3 raised to the 1st, times 2 raised to the 4th, times 5. Okay, enter. That's going to be the number 240. So this is going to be 240 x to the 4th. Plus, alright, now we need to do this one. Alright, let's bring our calculator back up. Okay, let's punch it in. We've got 3 raised to the 2nd times 2 raised to the 3rd times 10. Aw. Let me delete that out. Let's delete that out too. That's 310. Alright. Sorry. Times 2, 2 raised to the 3rd. And then times, there we go, times 10. Enter. Now 3 to the 2nd, 2 to the 3rd times 10 is 720. So we get 720. There's 720 x to the 3rd plus, alright, we need to enter the next one into the calculator. Let's see. This might be faster just by 3 times 3 times 3 times 2 times 2 times 10. Alright, I get 1080, so let's write that down. We have 1080 x squared. We're almost done. Still, this beats multiplying it all the way out by hand, okay? I know you're probably thinking, I could already been done. Well, if you could, more power to you. You might be able to go faster than I can actually type it onto the calculator. Let's do the next one. All right, we got 3 raised to the 4th. I'm going to punch that one in. 3 raised to the 4th times 2. Well, it hit times 2, and then to the 1st times 5. Enter. I get 810, so let's write that one down. Alright, plus 810x plus, finally, last but not least, let's see what we get on this one. We've got 2 to the 0, which is 1, times 1 times 3 raised to the 5th. Enter. We get 243. 243. And finally, this is our answer for that binomial expansion of 2x plus 3 raised to the 5th power. Now, you're probably thinking, well, how do I know if you're right? Well, I made sure to pull out my old TI-89 calculator and get a copy of it and put it on my computer, on the ROM and everything, so I could actually show you guys this. Now, this is a TI-89. I had one of these in college, and thankfully it has survived through the years, and I was able to put its ROM on my computer and everything. So let's check this out now. Now this computer can do all the algebra. Well, I should call it a computer, but it really is. These calculators, back when I was in college, were awesome. Okay, they would do a lot of the algebra for you. Okay, what I need this thing to do is expand this binomial. Okay, so I'm going to put the command expand, and what I'm going to expand is this 2x plus 3 raised, well, let me close the parentheses, raised to the 5th power. Now, it's been a while since I used one of these, so I think that's all I need to do, and I can hit enter, and it should expand it for me. I can't remember if I have to specify the x or not, but we'll see. Press enter. Oh, good, it did it. Now, check this out. The calculator did it instantly, a lot faster than myself. But let's check to see if we're right. I've got 32x to the 5th. The calculator's got 32x to the 5th. The calculator has 240x to the 4th. I have 240x to the 4th. Plus 720x to the 3rd. I have 720x to the 3rd. Plus 180x squared. 180x squared. Plus 810x. Plus 243. And I also had 243. So this is how you can use Pascal's triangle with binomial expansion. There's Pascal's triangle. Pascal's triangle to solve a binomial expansion problem. Okay. Now you're probably thinking, well, that only works because that was all pluses. Well, let's do one where we have a negative. That way you can see that this Pascal's triangle will work for all kinds. Okay. So here we go. Let me go ahead and draw a line and separate this. Okay. If you don't mind, I'm going to use another color. Let's use, I really like that purple, so let's use purple. All right. Let's say that we have the following. Let's say that we have 3x minus, we'll do 4. And this time we'll choose a different number. And let's say it's to the 4th power. Okay. Now we're going to do the same thing that we had done earlier. Okay. Oh, now I need you to really follow along with me. Okay, this is for the 4th power. So instead of using this one now, I'm going to be using this one right here. This is the one that we'll be using for this binomial expansion. Now the reason why we're going to be using this one is if we multiplied out with this one, it would be 1x to the 4th. There's the 4th power. You see it? Plus 3. Oh, excuse me. Plus 4x to the 3rd plus 6x squared plus 4x plus 1. Okay, but the reason why I'm keying in on this one is they gave me a binomial being raised to the 4th power. That's why I'm going to use this one. Okay, all right, so let's go ahead and go back down here. All right, so we know which one we're going to be using from the Pascal's triangle. We're going to be using these sets of numbers here, the 1, the 4, the 6, the 4, and the 1. And that is complements of Pascal's triangle. Okay, hopefully I spelled his name correctly. If I didn't, I am so sorry. All right, now there's Pascal's triangle, so let's do this. All right, we're going to need some room once again. If we're dealing with the x's, we know we're going to have x raised to the 4th. Okay, and we're just going to do a countdown. We're going to have x to the 4th. We're going to have x to the 3rd. Give some space. We know we're going to have x to the 2nd. Give some more space. And we know we're going to have a plain old x. And then we'll have a constant. So there's that. Okay, now we know we have to use Pascal's triangle numbers. Okay, so we're going to have a 1, we're going to have a 4, we're going to have a 6, we're going to have a 4, and on our constant we are going to have a 1. Okay, so there's Pascal's triangle numbers. Okay, now we do have a power of 4. Okay, so that's an even power, and we'll start on this side. Okay, so we're going to have a 3 to the 4th. And we're just going to count down with that, remember? We're going to have a 3 to the, instead of the 4th, we're going to have a 3 to the 3rd. And then we're going to have a 3 again, and this time it'll be 3 to the 2nd. And then we're going to have another 3, and it'll be 3 to the 1st. And then we'll have another 3 over here, but this time this 3 will be raised to the 0 power. Now, we're going to do the same thing again with the 4, but we're going to start on the other end, okay? This 4, okay, is going to be over here, okay? So let me go ahead and write that, okay? I'm going to use yellow for this. All right, so we're going to have a 4. Now watch this. We're going to have another 4. Now if you pay attention though, this is a negative 4, okay? We're going to have another negative 4 raised to the 4th. Now over here, we're going to have the same thing. We're going to have a negative 4 that's going to be raised to the 3rd. Okay, over here, we're going to have a negative 4 being raised to the 2nd. We're going to have a negative 4 on this one being raised to the 1st. And over here, we're going to have a negative 4. Notice I'm putting it in parentheses. We're going to have a negative 4 raised to the 0 power. Now, what that's going to do is that's going to make all of our even positioned coefficients, it's going to make their signs positive. Now, if it's in an odd placement, like a 1st degree, a 3rd degree, meaning their exponents are 1st, 3rd, and 5th, and 7th, then those odds would be negative. So anytime that you have a minus sign, the odd term is going to be negative. If it's even, it'll be positive. Okay, so all we got to do is we just got to punch this into the handy dandy cheatulator. So let's pull up our TI-84 again. All right, so here it is. Let's punch this in. All right, we've got parentheses. Now it's important to use parentheses. Parentheses, we've got negative 4, so we'll type in negative 4, close parentheses, raised to the 0 power. Now, to just save time, I want to show you that anything raised to the 0 power is the number 1. Unless it's 0, then I believe that's undefined, I think. Let me see. Because 1 raised to the 0 power is 1, but 0 raised to the 0 power is undefined. Oh, yeah, that's a no-no. Okay, sorry, I had to mention that. All right, so that's 1. So we have 1 times 3 raised to the 4th. Then we've got times 1. So this first term should be 81. All right, so we have 81 x to the 4th. Now we got this term to deal with, so let's deal with this. Whew. All right, I say deal with because this is a little bit of work. Okay, we've got parentheses. Negative 4. Close those parentheses because it's raised to the 1st. So raised to the 1st. Not really necessary, but I'm doing it. Times 3 raised to the 3rd. Good. Times 4. And that's all the numbers I see. Negative 4 raised to the 1st times 3 raised to the 3rd times 4. All right, press enter. That gives us negative 432. So let's write that down. Negative 432 x to the 3rd. Okay, next, let's do the next one. All right, bring up the calculator again. Now I'm kind of lazy. I'm just going to keep the same numbers and just change a couple. That way I don't have to type so much. So that's negative 4 raised to the 2nd. And then times 3 raised to the 2nd. Times not 4, but 6. All right, make sure that's right. Negative 4 raised to the 2nd. Negative 4 raised to the 2nd. Times 3 squared times 6. Good. Press enter. I get 864. Now remember, that's a positive. So that's positive 864 x squared. Okay. Hopefully I wrote that down right. Let's look one more time. Make sure. 864. Yeah, good. All right. Now let's deal with the next term. We've got, like I said, I'm lazy. I'm just going to repeat that and get it to do it for me. No sense in reinventing the wheel. That's going to be to the 3rd. And then times 3 to the 1st power. Times is it 6? No, this time it's going to be 4 again. So press enter. All right, I get negative 768. So let's write that down. Negative 768x. Finally, we'll get plus. Because remember, on these even ones, it'll be positive. All right, let's punch this into the calculator. We've got 3 to the 0, which we already discussed. Those numbers raised to the 0 power is 1. But be sure if you raise a number to the 0 power that you put it in a set of parentheses in the calculator. All right, so we get 1 times parentheses negative 4, close that parentheses, raised to the 4th. So press enter. We get 256. So let's write that down. That's going to be our constant there. So that's going to be plus 256. All right, so there's that. Now, like I said, wow, that's a really crooked line, isn't it? Let's see if that's actually right. I'm going to erase that box. That was pretty bad. So I'm going to box it in with orange. So let's see. Here we go. Woohoo. A little bit better. Not bad. All right, let's see what we got here. Okay, let's punch it in. Oh, we're going to test it on the TI-89. Okay. All right, here we go. Let's expand this out. Let's see what we get. Okay. Let me clear this one. We have parentheses. Hopefully we didn't make any mistakes. 3x minus 4, close parentheses, raised to the 4th. Now, I need to expand this out. So go back to the front. Press F2. Go down to expand, press enter. Make sure you end that command in parentheses because it opened up a set of parentheses. Press enter. All right, let's see if we got this. We got 81x to the 4th, good. Minus 432x to the 3rd, good. Plus 864x squared, good. Ooh, excitement building. Minus 768x plus 256. Well, there you go. All right, guys, I don't know if this video was helpful or not, or if it's just a blast from the past, or if you actually benefited from this or not. But remember, check out Pascal's triangle and use it when you're able to basically keep you from getting headaches when you're trying to do binomial expansion. So, all right, guys, one more time. This is Pascal's triangle, and watch it again, and y'all guys have a great day. See ya.